solve. To start, we're going to combine our terms. So 5.4 times 4 is 21.6x, and that equals 16.2. So to solve this, we need to divide both sides by 21.6, and that leaves us with x equals 0.75. You will need to solve the remaining equations for x. What do you notice about the three right rectangular prisms? I see a 5.5 in all three. I see a 3 in all of them. And I see a 4.2 in all of them. Make a hypothesis or a conjecture about how the volumes of these prisms would compare. I think since they have the same dimensions, that they would all have the same volume. We're going to assign one to ourselves. Let's do B. Consider the right rectangular prism assigned to you. Complete the table. So for B, our length is 4.2. Our width is 5.5. And our height is 3. Write a numerical expression that represents the volume of the prism in cubic centimeters. Remember, we do base, the bottom, times the height. Well, let's figure out the area of the bottom. The bottom is going to be 4.2 times 5.5, and then we're going to multiply that by the height. We can use the formula V equals the base area times the height to find the volume of a right rectangular prism. What do you think the variable B represents in this formula? And that is the area of the base. Do you think you get the same volume as if you were to use length times width times height? Well, yes, because the length times the width is the area of the base, like you see here. So in our case, the volume, 4.2 times 5.5, it has a base area of 23.1 and a height of 3, which is a volume of 69.3 centimeters cubed. Volume is three-dimensional, so it gets that cube. What do you notice about these three prisms? I see that the base is the same in all of them. The only difference between D, E, and F is the height. How do you think that will impact the volume? I think the taller it is, the more volume it's going to have. This time let's do F. So F has a length of 8 and a width of 1.5, and it has a height of 9. I'm going to change this 1.5 to an improper fraction. So remember, 1.5, we multiply. 1 times 2 is 2, plus 1 more makes 3. Use the formula B for base area equals the length times the width to compute the area of the base of the prism. Eight times 3 is 24. Remember, there's a little invisible 1 down here. 1 times 2 is 2, and 24 divided by 2 is 12. Then use the base area times the height, which is 9, to find the volume. 12 times 9 is 108. And this is measured in inches, and it is cubed for volume. A sheet of paper is folded into fourths as shown. Paper squares are placed at the top and bottom to make a right rectangular prism. Label the right rectangular prism with its length, width, and height. Well, the height is 11, and it stayed 11 the whole time. But 8.5 got split into 4 different sections. 8.5 divided by 4 is 2.125. So that is the base, or the length, and it is the width. And that is in inches. Compute the area of the base of the paper prism. Round your answer to the hundredths if needed. That is 2.125 times 2.125. And that comes out to 4.515625, but we're rounding to the hundredths place. And the 5 makes the 1 go up, so it is 4.52 inches squared for the base. For the volume, it's the base area times the height, which is 11. And that comes out to 49.72 inches cubed. This time the sheet of paper is folded into fourths, but it's oriented the other way. So instead of 11 tall, it is going to be 8.5 tall. And instead of 8.5 getting split into 4 parts, the 11 is split into 4 parts. Compute the area of the base. 2.75 times 2.75 is 7.5625. Rounded to the hundredth. The 2 tells the 6 to stay. Then for the volume, it's the base area times the height, which is 8.5. And that comes out to 64.26 inches cubed. Area is squared, volume is cubed. A company designs box A and box B to hold toy blocks. Find the volume of each box. Find the volume of the boxes. So we have 8 by 8 for the base here, which will be a base area of 64. And then we need the height of 8. So the volume for box A is going to be 64 times 8, which is 512 inches squared. Then for box B, let's do the improper fraction here. 12 times 5 is 60, 60 plus 4 is 64 over 5. Times 10 would give us the base. So that would be 640 over 5. But we can simplify that. So 640 divided by 5 is 128 for the base. And the height is 4. So then the volume for box 2 is going to be 128, the base area, times the height of 4. And that is also 512 inches squared. Part B, each toy block is a cube with an edge length of 2/5 of an inch. How many toy blocks does each box hold? Describe how the toy blocks are packed in each box. So let's see. 2/5. If we split 8 into 2/5, that can be rewritten as 8 times 5 over 2. 8 times 5 is 40, and 40 over 2 is 20. So we can fit 20 blocks across, 20 blocks wide, and 20 blocks tall in box A. "20 wide, 20 tall, 20 long." And that is 8,000 blocks that fit in box A. And the blocks are 20 rows of 20, stacked 20 high. Now let's go check on box B. For box B, we said this was 64 fifths. If we split that into 2/5, we can rewrite that as times 5 over 2. These 5s can be divided out. So we have 64 times 1 and 1 times 2. 64 split into 2 is 32 across. 10 split into 2/5, or times 5 over 2. It's going to be 50 over 2, and 2 fits into 50 25 times. So we have 32 rows of 25. 4 times 5 is 20, over 2 is 10, so stacked 10 tall. 32 rows of 25 stacked 10 tall. And that is 32 times 25 for the base, times 10 for the height. 32 times 25, and then multiply that by 10, is also 8,000 blocks that fit into box B. Suppose another type of toy block is a cube with an edge length of 1 3/5 inches. How many of these toy blocks does each box hold? Describe how the toy blocks are packed in each box. Well, that would be 1 times 5 is 5, plus 3 more is 8. So this is 8/5. For box A, we had 8 across. So how many boxes 8/5 wide can we fit in there? These will divide out, leaving us with 1. So that is 5 across. 5 rows of 5 stacked 5 tall. And 5 times 5 times 5 is 125 blocks that will fit into box A. For box B, we have 4 inches tall. We have 64/5 wide and 10 across. Four times 5 is 20. 20 divided by 8 . Well, 8 fits into 20 2 times with 4 left over, but we're not going to be able to fit 4/8 of a block. We're not going to have a partial block, so we're just going to get 2 tall. These divide out, so I have 64/8, and 64 divided by 8 is 8. 10 times 5 is 50. 8 fits into 56 times, which gives us 48 with 2/8 left over. But again, we can't have a partial block. So this one will be 8 rows of 6 stacked 2 tall. And 8 times 6 times 2 is how many blocks are going to fit in there, which is 96 blocks. The company creates a new box with a volume of 448 cubic inches. If the area of the base of the box is 64 square inches, what is the height of the new box? So remember, we find the volume by the base area times the height. It tells us here that the volume is 448, so we can replace V with 448. And it also tells us the area of the base is 64, so I can replace that capital B with the number 64. To solve this, h is being multiplied by 64, so to undo multiplication, I can use division. That leaves me with h, and 448 divided by 64 is 7. And that is measured in inches, so 7 inches for our height. Down here, it says, if the new box has a length of 12 4/5 inches and a width of 10, what is the height? Well, let's start by calculating the base area. Again, I don't love the mixed numbers. I prefer it as an improper fraction. So 12 times 5 is 60, plus 4 makes 64/5. And we're multiplying by 10. 64 times 10 is 640. 5 times 1 is 5. Then we'll simplify that by dividing by 5, and that is 128 for our base area. Our volume is still 448. This time our base area is 128. So if I want to solve it for h, I'm going to divide both sides by 128. Those divide out and leave me with just an h. And 448 divided by 128 is 3.5. And that is measured again in inches. That wraps up lesson 16. Make sure that you have your work written in your workbook and your warm-up completed, and then check back for more Module 5 videos.